We're going to look at some different angle relationships when we have chords that intersect inside and outside of a circle. If you have chords that intersect inside a circle, to find this angle measure, and these are vertical angles, so you could also find this angle measure. You find the measure of arc AB plus the measure of arc CD, and then divide that number by 2, and that'll tell you one of those angles. If you have intersecting chords outside of a circle, to find this angle measure, you do the big arc minus the small arc. So here you were doing 1 arc plus 1 arc divided by 2. Here you're doing the big arc minus the small arc divided by 2. And then another important relationship to see is if you have a radius that intersects with a tangent, that makes a right angle. And here there's another radius that intersects with a tangent, so that's making a right angle, which means this angle and this angle are supplementary. This makes a quadrilateral, which means all the angles add up to 360 degrees. And if here's 90 degrees and here's 90 degrees, that leaves 180 degrees left that these two angles add up to. Now let's apply these to some problems. In number 1, the intersection of the two chords is inside of the circle, so we want to use that first formula where we add up the two arcs and divide by 2. That's from this formula. So 111 plus 61 divided by 2, and that's 86 degrees. This next one, the intersection is also inside the circle, so we add up the two arcs, 82 plus x, we don't know what that arc is, divided by 2, that equals 58 degrees, one of those angle measures. So we can multiply both sides by 2. Now we have 82 plus x equals 116, subtract 82, so x equals 34 degrees. For this next one, the intersection is outside the circle, so we want to do the big arc minus the small arc divided by 2, and that's 47 degrees. The next one, it's also outside, but we're only given one angle measure. We can find this one though, because if this part is 238 degrees, then this part has to be 360 minus 238 in order for it to be a whole circle. So that gives us 122 degrees there. And now we can subtract those and divide by 2. And you get 58 degrees. The next one, the intersection is on the circle. It works similar to an inscribed angle where the angle measure is going to be half the measure of the arc that it opens up to. So that's 136 divided by 2. It might help in visualizing why we can do that if you think of a circle that has a tangent intersecting a diameter specifically for the other chord. Well, this is 180 degrees because it's a semicircle, and this is 90 degrees. So we see that that angle is half the measure of the arc. And then finally for this last one, if you remember, these two angles are supplementary. So 42 plus x is 180. Then we can subtract 42 and we get 138.